Globes are made to represent the world. A globe is a special kind of map. It shows the world as we think it might look to someone far out in space. A globe shows us the land and water portions of the earth. It shows us the oceans and the continents and their general shape. But how do we know that the actual shape of the earth may be shown by a globe? How do we know what the earth's shape really is? Let's see. Many thousands of years ago, early man looked at his world. He thought perhaps that it ended at the horizon. He may have asked himself, is the world flat, and does the horizon mark the falling off place? Years later, people living near the sea noticed an interesting fact. They saw that ships heading out to sea in any direction seemed to sink and disappear below the horizon. They knew that the ships didn't really sink, so they explained what they saw in this way. On a flat earth, a boat leaving the shore would simply disappear in the distance. However, if the earth were curved, a boat would seem to sink lower and lower as it sailed away. So they thought that the earth must be curved. Ancient Greek scientists thought that the earth was round because of what they sometimes saw when they looked at the moon. At certain times, the full moon became dark, as though a giant shadow were passing over it. What happened is shown in this diagram. The earth blocked off the sun's light and formed a shadow. The Greeks knew that the moon traveled around the earth. When it entered the earth's shadow, it seemed to disappear. The Greeks called this an eclipse. These motion pictures of an eclipse were photographed through a telescope on Mount Wilson in California. We can see the edge of the Earth's shadow on the moon. The movement is speeded up because this eclipse takes almost 2 hours. It was this same curved shadow crossing the moon which the ancient Greeks saw. From the shape of the shadow, they were able to tell the general shape of the earth. They decided that since the earth's shadow is round, the earth itself must be round. Columbus, along with many other men, knew about the idea of a round earth. If the world were round, Columbus believed, it should be possible to sail around it. He failed in his attempt because America was in the way. A few years later, however, a sea captain named Magellan set sail from the country of Spain. His ship sailed westward. Finally, after many adventures, one ship arrived back at its starting point. This voyage proved that the world is round. But then, about 300 years ago, Isaac Newton, a great English scientist, said that the earth could not be perfectly round This model, made of steel bands, shows why he believed this. When the model turns slowly, it has a round shape. But when it turns quickly, it bulges out in the middle and flattens on the top and bottom. Newton said that since the Earth spins rapidly, its sides must bulge out and its poles must be flattened. Later, it was proved that Newton was right. The distance through the Earth from pole to pole is 27 miles less than its distance through the middle. This means that the Earth is slightly fatter from side to side than from top to bottom. The shape of the Earth is like a slightly flattened ball. In this drawing, the flattening and bulging is shown much greater than it really is, so we can see it clearly. But today, satellites traveling around the Earth have given us better ways to measure the Earth's shape. Special receivers on the ground pick up radio signals sent by satellites. You are listening to a recording of the signals received from Vanguard 1, one of the early satellites. From information received from a satellite, scientists can tell its position. They can also tell the path it follows around the Earth. Because the Earth bulges slightly in the middle, scientists knew that a satellite's orbit would slowly change, like this. However, after observing and measuring actual satellite orbits, they found other changes they hadn't expected. Very careful studies of satellite movements proved that the Earth not only bulges in the middle and is flattened at the poles, but that the Earth also dips in a few feet around the northern hemisphere and bows out a few feet in the southern hemisphere. Remember, the differences here and here are very, very small. Only a few feet in many thousands of miles. In this drawing, the differences are shown much greater than they really are, so we can see them clearly. The Earth may be described as being very slightly pear-shaped, but the dips and bulges are so small that if you were far away in space, the Earth would look perfectly round. In recent years, scientists have found new ways to look at the Earth. Cameras placed in rockets have photographed the Earth from great heights. These pictures were taken from a rocket 700 miles above the Earth. They show clearly the curve of the Earth's surface. So, man has learned about the shape of the Earth in many ways. By watching moving ships, the Earth's shadow on the moon, rapidly turning objects, the orbits of satellites, and photographs like these. As we know now, the actual dips and bulges in the Earth are very, very slight. To scientists, however, even a difference of a few feet in many thousands of miles may be of great importance. For normal study, a perfectly round globe is still the best model we can conveniently make. If the Earth itself could be shrunk to the size of a school globe, it would appear rounder and smoother than any globe ever made.